Hi, and welcome to Polynomials Day 1. I don't usually have all the writing up before we start the videos, but I've been having a few issues with the computer the last 2 nights, so I already created the video once and lost it. So what I'm going to do is just walk you through it. If you need to, hit pause so that you can copy what you need to and then listen to what I'm going to say. So today we're talking about successive differences in polynomials. John noticed patterns in the arrangements of numbers in the table. So my first row labeled numbers is 2.4, 3.4, 4.4, 5.4, 6.4, and as you see they're all increasing by 1, so 7.4 and 8.4 would be next. And then we have the squares of the numbers up above, 5.76, 11.56, 19.36, and so on. And then we have what we call the first differences, 5.8, 7.8, 9.8, 11.8, and then 13.8 and 15.8. And we have our second differences, which are all 2, 2, 2, 2, and 2. So assuming that the pattern would continue, he used it to find the value of 7.4 squared. Explain how he used the pattern to find 7.4 squared, and then use the pattern to find 8.4 squared. So what John noticed is when he subtracted 5.76 and 11.56, he got 5.8. And when he subtracted 5.6 and 19.36, 11.56 from 19.36, he got 7.8. And then when he subtracted 29.16 and 19.36, he got 9.8. And then when he subtracted 40.96 and 29.16, he got 11.8. So in order to get to the next number, he knew that this number here, which I have filled in already, and this one, when I subtract them, need to give me 13.8. So if I take the 40.96 and add to it 13.8, I get 54.26. Using that same line of thinking, John could find 8.4 because he knew he could add 15.8 to the 54.76 and get 70.56. Kind of ignore this question because we don't need that. Done. All right. So another example similar to we had up above, just some numbers put together. If we have numbers 1, 4, 9, 16, 25, and 36, and those are all perfect squares, and I wanted to find the first differences, all I would do is subtract the two numbers. 4 minus 1 gives me 3, 9 minus 4 gives me 5, 16 minus 9 gives me 7, 25 minus 16 is 9, and 36 minus 25 is 11. To find my second difference, I'm going to subtract 5 minus 3, get 2, 7 minus 5, get 2, and 9 minus 7, and get 2. So, what is the sequence of the first differences for the linear polynomial given by ax plus b, where a and b are constant coefficients? Well, linear and ax plus b is the same thing because that's y equals mx plus b form, and that is a linear equation like we talked about in the last unit. So what I need to do is just substitute in the numbers 0 through 4 into x, into this equation right here, sub in here, okay, sub in 0 through 4 here, not her, here. So when I do that, if I put in 0 for x, I get b. If I put in 1 for x, I get a plus b. If I put in 2 for x, I get 2a plus b. And this is a 3a plus b when I substitute in for x. And when I put in 4 for x, I get 4a plus b. Then they asked me to find the first differences, which just means subtracting my terms. So to find my first term in my sequence, I would do a plus b minus b, and I get a. And then I would do 2a plus b minus a plus b, and I'd get a. And then I would do 3a plus b minus 2a plus b, and I get a. And then I do the fourth term, which is 4a plus b minus 3a plus b, and again I would get a. So therefore, that's what these three dots mean, therefore, the differences are a, and it would just keep on going. For the first difference of a first degree polynomial expression is a constant a. Linear is a first degree because the exponent that we don't have there implies that it would be a 1 if it were written there. So what is the sequence of the second differences for ax plus b? Well, if all my terms are a, then I just subtract a minus a and get 0. So all my second differences are 0. All right. So find the first, second, and third differences of a polynomial ax squared plus bx plus c by filling in the blanks in the following table. So since this is x squared, that means it's a second degree polynomial. And what I'm going to do, again, is substitute in these x values into this equation. And when I put in 0, I get c. 1 gives me a plus b plus c. 2 gives me 4a plus 2a plus c. 2b plus c. 3 gives me 9a plus 3b plus c. 4 gives me 16a plus 4b plus c. And 5 gives me 25a plus 5b plus c. Now to find my differences, I need to subtract these two here. So a plus b plus c minus c. C is a plus b. When I subtract these two, I get 3a plus b. When I subtract these two, I get 5a plus b. When I subtract those two, I get 9a or 7a plus b. And when I subtract the last two, I get 9a plus b. To find my second differences, I subtract 3a plus b minus a plus b, and I get 2a. And 3a plus b, 5a plus b minus 3a plus b, I get another 2a. And when I subtract there, I get another 2a. And when I subtract there, I get another 2a. And finally, to find the third differences, 2a minus 2a is 0, 2a minus 2a is 0, 2a minus 2a is 0. So I filled in my chart. No big deal. Oh, one thing I'm going to point out is my second differences right here. What's 2a for everything? So example 3. Find the second, third, and fourth differences of the polynomial ax cubed plus bx squared plus cx plus d by filling in the blanks in the following table. And this is a third degree polynomial because that is a power of 3. So again, I'm going to take these x values here, substitute them into this equation right here, and I get the following equations. And then I have to subtract those two, and I get that one, those two, and I get 7a plus 3b plus c. When we subtract those two, we get 19a plus 5b plus c. Those two, and those two. And then I have to subtract again to find the second differences. So this time I'm going to subtract these two right here, and I get 6a plus 2b. When I subtract these two, I get 12a plus 2b. When I subtract those two, I get 18a plus 2b. And when I subtract those two, I get 19a plus 2b. Finding my third differences, subtract those two, I get 6a. When we subtract these two, we get 6a. When we subtract these two, we get 6a. And then finally, we get zeros for our fourth difference. So a third degree polynomial, our third difference is 6a. make sure I remember that. That's important later on. All right, example 4. What type of relationship does a set of ordered pairs x, y satisfy? How do you know? Fill in the blanks in the table below to help you decide. The first differences have already been computed for you. All right. So these are all ordered pairs: 0, 2, 0, 1, or sorry, 1, 1, 2, 6, 3, whatever, 23, 4, 58, 5, 1, 17. They've already been substituted in and subtracted, and these are my first differences here in this column. Now I need to find my second differences. So when I subtract 5 minus a negative 1, I get 6. 17 minus 5 is 12. 35 minus 17 is 18. 59 minus 35 is 24. Then I need to subtract again. 12 minus 6 is 6. 18 minus 12 is 6. 24 minus 18 is 6. These are my third differences. They're constant. And they could represent a cubic relationship between x and y. So the third differences are constant, and they can, or they could represent a cubic relationship between x and y. So find the equation in the form right here. Ax cubed plus bx squared plus cx plus d, that all ordered pairs x, y above satisfy. Give evidence that your equation is correct. Well, I know from the previous page that my third differences are 6a. No matter what I do, my third differences are always going to be 6a. So therefore I could say 6a equals 6 because that's what we found in the chart above, that my third differences were equal to 6. If my third differences were equal to 12, I would say 6a equals 12. But in this case, it's 6a equals 6. So a equals 1. So right now I have one of my coefficients and I need to find another one. Well, if I go back up here, 0, 2 is an ordered pair on the graph. So I can put in 0 for x and 2 in for y. So when I substitute in 2 in for y and 0 in for x, and I also knew that a was 1, I get 2 equals d. And then I need to find c and d. And in order to find c and d, I'm actually going to put 2 equations with 2 unknowns. And when I do that, I'm going to just go back up here and look at some more ordered pairs. I have 1, 1, and 2, 6. So I'm going to use this one first, and then this one to find my 2 equations, and my 2 unknowns. So I'm going to substitute in 1, 1 into my equation. When I do that, I have 1 equals, because this is x and this is y. I have 1 for y, 1 for a, 1 for x, 1 for x, 1 for x. And when I simplify, I get negative 2 equals b plus c. So I still have 2 unknowns. So now I got to sub in the 0.26, do the same thing as I did before. So y is 6 and x is 2. A we already know is 1. And this is a 2, and it just didn't want to write there earlier. So plus 2. And I substitute in a 2, I have 8, 4b, and 2c, plus a 2, and my 6. So I combine like terms, and I have 6 equals a plus 4b plus 2c. Subtract my 10. So negative 4 equals 4b plus 2c. So now I have this equation here, and this equation here. And these are 2 equations that have the same variable, both b and c. And it's 2 equations with 2 unknowns. So what I'm going to do is use the elimination method, and I need to get either b or c to cancel out. And the easiest way to do that is to multiply my bottom equation here by this negative 2 out in front. And when I do that, my negative 4 will still be equal to 4b plus 2c. But my bottom equation becomes a positive 4 equals negative 2b minus 2c. My two C's cancel out. Negative 4, positive 4 gives me 0. Positive 4 and a 2b give me 2b. And when I divide by 2, I get b equals 0. Now that I know that b is equal to 0, I can use either one of my two equations. And I'm going to use this one here and substitute in 0 for b. So I get negative 2 equals 0 plus c. So that means that c has to be negative 2. And in order to write the equation, because that's what they were looking for, y equals x cubed, because a was with the x cubed. I don't have a square term because b equals 0, so that whole term will 0 out. And then minus 2c, because c was negative 2, sorry, minus 2x, because c was negative 2, plus 2, because d was 2 in our original problem. Now I know I probably went fast with that. I hope you were able to pick some of that up. We will definitely go over this in class again. Write down any questions you have. And if you need to, go back and rewatch certain parts. All right, thank you.